Hey, Seward Middle School students. Today's goal, the goal of today is to help you with the basics of forces and vectors, okay? As we begin to understand how to draw and describe what's happening with objects in motion or not in motion, we use vectors or arrows to show what's going on, what forces are acting on them. Don't be concerned or stressed about vectors. They are just arrows, okay? Just special arrows. And what those arrows show us or tell us is how big the forces are and what direction they're moving, okay? And from those arrows, we can understand what's happening with the object. So let's start with a cute little girl on her skis. Kind of reminds me of my daughter. She is not in motion right now. She is stationary. So first of all, when we're going to draw or describe what's happening with her, we have to think about what forces are acting on her. So first of all, we think, what's one force that acts on all objects on this earth at all times? And that's gravity. Okay, so I know that gravity is acting on her. And then I have to think which direction gravity is acting. And I know it's always going to point straight down. Okay, so I'm going to put my arrow pointing straight down. Then I have to think what force is opposing that motion. She's not moving. So the forces always happen in pairs. And right now we just have one downward arrow. No matter what you do, that gravity arrow always points straight down. Okay? Even if you're on a hill, it's straight down. Okay. And this arrow is this size because of the size of the person. So the arrow depends on how much force. I know that there is an equal and opposite force acting on her because she's not moving. And if I say equal and opposite, that means my arrow has to be the exact same size and pointing the opposite direction. Because the arrows are the same size, I know the forces are equal. Okay, so that size is important. And that force that is acting on her is called support force. It's the force of the ground, holding her up against gravity. It's the force of the chair pushing on my butt that I'm sitting on right now. If the chair wasn't under my butt, if that force wasn't there, if you pulled it out from under me, I would fall because gravity would be the only thing acting on me and pull me down. So support force is the force of chairs, desks, tables, floors, houses pushing up against us, opposing gravity. If gravity is bigger than support force, things come crashing down. So notice that these arrows are equal and opposite. Okay, and they show the direction of motion. Now, if I look down here to this skier, the skier that's moving, okay, this skier has jumped into the air and he's in the process of dropping down. So I know gravity is also acting on him as well. And the reason I'm doing this in Google Draw is so you can kind of start to see how easy it is to make these projects on here. And I'll show you how to make the arrows in a minute. Okay, so then I'm going to take this arrow to represent his gravity, the force of gravity on him. Notice that the arrow is bigger. The arrow is bigger because he's a bigger object and there's more gravity acting on him. The bigger arrow tells me it's a bigger force, and it's always pointed downhill. Now, what force opposes motion, acts against it, slowing all things down as they try to move? As he's dropping to the ground, he's falling through the air. Those air particles are rubbing up against his body, producing little bits of heat and stealing little bits of his kinetic energy, slowing him down. The force that opposes all motion is friction. So that's going to be my other force. Now, he's falling downward, so I know that friction arrow is going to be much smaller than the gravity arrow because it's a smaller force, okay? And it's acting in the opposite direction. It's trying to slow him down, okay? So it's a smaller force, so it's a smaller arrow. Friction arrow always goes opposite the direction of motion. If he was going forward, the friction arrow would point backward. This here is an example of what we call unbalanced forces. Unbalanced, because one force is larger than the other. Pretty simple. One arrow is bigger than the other. Almost all motion on this planet is produced by unbalanced forces. One force big enough to push it. Somebody comes along and pushes that little girl, she's going to move forward because that's going to be an unbalanced force in the forward direction. If her legs give out, she's going to fall to the ground. The little girl who's not moving is what we call an example of balanced forces, because the forces on her are equal and opposite. The arrows are the same size. Balanced forces means the object's going to keep doing what it's doing. It's not going to move. It's not going to change what it's doing. Okay. If you wanted to make something quick and easy on here, just to see if you can think about it, if we throw a ball in the air, I need to make a vector that shows what's happening with that force. Somebody threw that ball in the air, up and over. Maybe it was a football. So that arrow is the force of the upward, outward throw. And what do we say acts against all motion? Friction. But the ball is moving forward, so we know that arrow is going to be smaller. So I'm going to make that arrow smaller because it's a smaller force. Okay, force of throw, force of friction. Bigger arrow, bigger force. Smaller arrow, smaller force. The force of a throw, an engine, a person is what we call the applied force. And you can just call it in general or name it like force of legs, force of body. I hope you feel a little more comfortable with drawing vectors to show motion. Remember that vectors are just arrows, nothing fancy. You got this.